Let us continue nitro compounds. In the nitro compounds, nitrobenzene will take nitrobenzene. Now, this phenyl group will go for electrophilic substitution. This phenyl group will go for electrophilic substitution. This phenyl group going for nucleophilic substitution. Nucleophilic substitution is difficult. This phenyl group will go for electrophilic substitution. Going for nucleophilic substitution is difficult. Now we will take a aryl benzene. We will take aryl benzene. This aryl benzene. Now this aryl benzene, that means suppose we will take nucleophile. This nucleophile is attacking this part and this Cl is leaving, so we will get so and so product. So and so product. Here we can say Cl minus is replaced by nucleophile, therefore we can say it is called a nucleophilic substitution reaction. Nucleophilic substitution reaction we can say. But what is the problem in the sense here between this carbon and chlorine, partial double bond is there. Therefore, nucleophile unable to attack this carbon, so that this chlorobenzene is not going for nucleophilic substitution. It is not going for nucleophilic substitution. So, now we will take chlorobenzene. Chlorobenzene will take. Now what we will do in the sense, we will introduce electron withdrawing group at ortho position and at para position. So we are introducing electron withdrawing group at ortho position and para position. We introduced electron withdrawing group. We introduced. Now what happens? We will see. We will take the nucleophile. Nucleophile is OH minus. Nucleophile is OH minus. Now this nucleophile is attacking this carbon. Attacking this carbon, then what is leaving in the sense this Cl minus is leaving, so we are getting this compound. Here NO2, here NO2. Now Cl minus is leaving. Now see, Cl minus is leaving. It is leaving group. Instead of Cl minus, what is coming? OH minus is attacking this. So OH minus attacking this means it is nucleophile. So it is called a nucleophilic substitution reaction. It is called a nucleophilic substitution reaction. This is possible. Here it is chlorobenzene. It is going for nucleophilic substitution. Here also chlorobenzene. It is not going for nucleophilic substitution. This chlorobenzene is not going for nucleophilic substitution, but here chlorobenzene is going for nucleophilic substitution. Why is it so? That we'll see. Because what is the reason for this in the sense this NO2 group is electron withdrawing group is present. Here NO2 group is electron withdrawing group. Now due to these two electron withdrawing groups, what will happen? That we'll see. Because of these two electron withdrawing groups, what will happen? We'll see. First we will take orthonitrobenzene. We'll take. First we will take orthonitrobenzene. For it is benzene we have taken. So first we will take one nitro group like this. One nitro group we have taken like this. Now here this nitro group, in this nitro group, this nitrogen is having positive charge. This nitrogen is attached to this carbon. This nitrogen is having high electronegativity than this carbon. So this nitrogen is acting as electron withdrawing group. It is pulling this sigma bonding electron cloud towards itself. Therefore it shows minus I effect. So now what we said, this N plus is having high electronegativity than this carbon. So this sigma bond is moving towards N plus. So N plus shows minus I effect. This carbon shows plus I effect. Next. Here this double bond, it is multiple bond. Here double bond. This double bond and this double bond is separated by this single bond. So this double bond and this double bond are in conjugation. Due to conjugation, resonance is possible. What is the resonance? That we'll see. Now pi bond is shifting towards this oxygen because it has high electronegativity. Therefore, this pi bond is shifting towards this side. So what we will get, we will see. Now here this single bond becomes a double bond. This N single bond O minus, single bond O minus, N is having positive charge. Now this pi bond and this pi bond we will write. Then this carbon is losing the pi bond, so positive charge for this carbon. Okay. Next resonance structure. Next resonance structure we will write. Next resonance structure, this pi bond is shifting to this place. So pi bond is shifting to this place. This pi bond no change. Here double bond N plus O minus O minus. Now this carbon is losing the pi bond. So this carbon is getting positive charge. Next we will see. Next resonance structure we will see. Next resonance structure. Next resonance structure. This pi bond is coming to this place. So for this pi bond no change. Here one pi bond is creating. This double bond N plus O minus O minus. Here this carbon is losing the pi bond, so getting positive charge. So now you see that because of this NO2 group, this NO2 group is acting as an electron withdrawing group. Due to that, this with respect to this, it is ortho position. This ortho position is getting positive charge. It is ortho position. Ortho position is having positive charge. Then with respect to this is para position. Para position is having positive charge. With respect to this, it is ortho position. Ortho position is having positive charge. So nitro group is acting as electron withdrawing group. It is creating positive charge at ortho and para position. So NO2 group is electron withdrawing group. Because of this NO2 group, ortho position, this position, at this position, it is creating positive charge. This NO2 group is electron withdrawing group. It is creating positive charge at this position. This NO2 group is electron withdrawing group. It is creating positive charge at para position. For this, it is a para. So due to this NO2 group, here positive charge is created. Due to this NO2 group also, here positive charge is created. Because of positive charge, this nucleophile easily attacking. Therefore, it is going for nucleophilic substitution reaction. So because of these two electron withdrawing groups, this compound is going for nucleophilic substitution reaction, we said. Okay. So now we will distinguish nitro compounds and nitride compounds. Nitro compounds and nitride compounds, a distinction we will see. Now we will take a nitro compound RCH2NO2. To this we will add a reducing agent, that is metal in acid we will add. What will happen here? Here this NO2 group is converting into NH2 group. NO2 group is converting into NH2 group. Okay. So NO2 group has converted into NH2 group. Now we will take nitrite. We will add same reducing agent, metal and acid we will add. So what happens here? Here what is happening in the sense, this tin and HCl is supplying what we will see. Tin and HCl will supply what in the sense, it will supply nascent hydrogen. So how it is supplying nascent hydrogen, that we will see. Tin is converting into Sn2 plus 2 electrons. In this HCl, H plus is there. H plus takes this electron and becomes nascent hydrogen. This nascent hydrogen is attacking this place. In what way it is attacking, that we will see. This side 1H, this side 1H. Here this bond is breaking, 1H, 1H. Another bond is breaking, H and H. So this is becoming OH, alcohol. This is becoming OH group, alcohol group. This is ammonia, this is water. So nitrite on reduction with reducing agent metal plus acid gives alcohol. Whereas nitro compound on reduction with reducing agent tin and HCl gives amine. So nitro group is converted into amine, whereas nitrite is converted into alcohol with the reducing agent metal plus acid. It is a distinction between nitro compound and nitrite compound. What is another distinction that we will see? Now we will take a nitro compound or CH2NO2 will take. To this what we will add means sodium hydroxide aqueous we will add. What we will get in the sense, we will get a salt. Now we will take a nitrite, we will take, or CH2O NO will take. This is taken for hydrolysis in the presence of sodium hydroxide aqueous. So here what we will get, that we will see. Now in this case, here this bond is breaking, here H plus and here OH minus. Okay, therefore what we are getting means this O is this O is taking this H plus and becoming alcohol. So alcohol. This is HNO2, HNO2. HNO2 with sodium hydroxide. With sodium hydroxide gives salt NaNO2 and water. Okay, so this part with sodium hydroxide gives NaNO2. Sorry, anyhow, this nitrite is converting into what functional group? Alcoholic functional group. Nitrite is converting into alcoholic functional group on hydrolyzing in the presence of base. What about nitro compound? That we'll see. Nitro compound in the sense this is RCH2 NO2. NO2 we can write like this. So here what is happening? Here what is happening means this bond is migrating, this bond is migrating, hydrogen comes to this place. So it goes for resonance. So in the resonance here double bond, here N plus, here OH, here O minus. It is called acid form. It is called acid form. Now sodium hydroxide comes for reaction. So OH minus will write. What happens means this is becoming water and this is becoming O minus, and that O minus is stabilized by Na plus. O minus is stabilized by Na plus, we can say. So we will get RCH double bond N plus, here O minus Na plus, here O minus. This water is water leaves. So we are getting what in the sense we are getting salt. We are getting, in this case we are getting salt. Okay, we are getting a salt, we are getting in this case. So nitro compound on hydrolysis in the presence of base gives salt. Nitrite on hydrolysis in the presence of gives alcohol. Nitrite on hydrolysis in the presence of sodium hydroxide gives alcohol, we can say. Okay, this is in the NCRT. It is which chapter in the sense organic chemistry volume 2, last but one chapter, last organic chemistry chapter, that is nitro compounds, amines, diazonium salts, like this will be there. Organic compounds containing nitrogen in the functional group. In that chapter this part comes. Okay, next we will see about amines. Amines is the functional group. We will see about amines. In amines we will take one amine is this one, it is amine. Next amine we will take like this. Next amine we will take so and so. Next amine will take, next amine will take like this. So this is called this here amine. In that amine nitrogen is having two hydrogens. It is primary amine. This nitrogen is having only one substitution. Here nitrogen is having one H. This nitrogen is having two substitutions. So it is secondary amine. So secondary amine means nitrogen is having one H. Here this N is not having H. It is having three substitutions. This N is called tertiary amine. Here N is having four substitutions. This is called what means quaternary ammonium salt. It is called quaternary ammonium. Why we have to call it as ammonium means NH4 plus is called ammonium ion. Therefore in NH4 plus charge is there on nitrogen. So like this nitrogen is having positive charge, therefore ammonium. Okay, then here plus charge and minus charge is there, therefore it is what means salt. So we can say quaternary ammonium salt, we can say. So we have taken what in the sense primary amine, secondary amine, tertiary amine and quaternary ammonium salt we have taken here. Now we will see some of the IUPAC names. We will see. Now we will take some of the IUPAC names. First compound we will take CH3, CH2, CH, NH2, COOH. Like this we will take. In this one, what are the functional groups are present in the sense? One is carboxylic acid, another one is amine. Two functional groups are there. Which is getting higher priority? Carboxylic acid. NH2 gets a lower priority. So higher priority means main functional group. Lower priority means substituent. So we have to give numbering in what way? In the sense number 1 to carboxylic acid we have to give because that is having higher priority. Okay. Now we will say this amino group is substituent, so we have to say as a prefix. So prefix in the sense NH2 is called as amino. It is present at second position, so 2 amino we can say. 4 carbon atoms, therefore but we can say. And carbon-carbon single bond, therefore ane. And carboxylic acid we have to say as a oic acid, we have to say. Carboxylic acid is called oic acid. So this name is 2 amino butanoic acid, we can say. Next compound we will take CH2, NH2, then CH2, CHO, like this we will take. In this case, 2 functional groups are there. One is amine, another one is aldehyde. One functional group is amine, another functional group is aldehyde, we can say. Here, out of these 2 functional groups, aldehyde is a main functional group. So for aldehyde carbon number 1, we will give, it is number 2, it is number 3. This NH2 is a substituent. It is not main functional group. Substituent means we have to call it as amino. It is present at 3rd carbon. Now, totally 3 carbons present. 3 carbons means prop, and carbon-carbon single bond. So primary suffix is N, and aldehyde means secondary suffix, that is Al. Aldehyde means secondary suffix, that is Al, that is main functional group. So name of this compound is 3-amino-propanol. Next we will take next compound NH2, NH2 single bond, CH2, CH2, Cn. This compound we will take. In this compound, 2 functional groups are there. One is amino group, another one is cyanide, which is having higher priority, means cyanide is having higher priority. So first number we will give to cyanide carbon. It is second number, it is third number. This NH2 present at 3rd carbon. So we can say it is 3 amino. 3 carbon atoms, so that prop, and carbon-carbon single bond. So primary suffix N. Cyanide means main functional group. So it is coming under secondary suffix. It is called what means nitrile. It is called nitrile, we can say. Here in this nitrile, in this nitrile is the secondary suffix. The first letter is not vowel sound. First letter is not vowel sound in the sense we have to include what? We have to include E, we have to include, therefore primary suffix is what means N. Okay, so in this case we will say first prefix, then root word, then primary suffix, then secondary suffix. What is a root word? What is a root word means 3 carbon atoms, therefore prop is a root word. What is a prefix means substituent is a prefix. Substituent is NH2. NH2 is said as amino. This amino group present at 3rd carbon, so 3 amino. Primary suffix is carbon-carbon single bond, that is N. Secondary suffix is cyanide. Cyanide secondary suffix is what means nitride. So the name of this compound is 3-amino-propane nitrile. Now we can say that here in this case, in the nitrile, the first letter is not vowel sound, so we should not drop this E. Don't drop E. Keep this E as it is, so that the name of this compound is 3-amino-propane nitrile. Okay. Now we will go for next compound. Next compound we will take it as a CH2, NH2, then CH2, CH double bond CH, COOH we will take. In this one, how many functional groups are there in the sense one is carboxylic acid, another one is a double bond, another one is NH2 amino group. Out of these 3, which is main functional group means carboxylic acid. So carboxylic acid gets least position in numbering. So it is 1, here 2, 3, here 4, here 5. So first we will say NH2 name, that NH2 present at 5th position, so 5 amino. 5 carbon atoms present, therefore pent. CC double bond present, therefore ene. Carboxylic acid means oic acid. Now we can say that in this oic acid, first letter is O, that is vowel sound, so drop E here. And this double bond present at 2nd and 3rd carbon, so take in that least position, that too you mention it. So the name of this compound is 5-amino pent 2-ene this oic acid, 2-enoic acid. Okay, so name of this compound is so and so. Next we will take a next compound CH3CH, OH, CH, NH, C2H5, then CH2, CH3. This compound will take. In this compound, what are the functional groups are there? One is alcoholic functional group, another one is a secondary amine. It is called what means secondary amine. So one is alcoholic functional group is present. This alcoholic functional group is the main functional group. This secondary amine is not the main functional group. Okay, sir. So alcoholic group is the main functional group. So you give the numbering such that this alcoholic carbon will get least position. So number 1, number 2, 3 year, 4 year, 5 year. So like this we have given. Now this is secondary amine. This secondary amine comes as a prefix. So this NH is amine. Its prefix name is what means amino. Next, this ethyl group C2H5 is called ethyl group. Ethyl group is connected to nitrogen directly. So we have to call that is as N-ethyl. N-ethyl we can call. This is NHC2H5 is called N-ethyl amino. It is present at which carbon means third carbon. So 3 we can say. Totally here 5 carbon atoms are there. Therefore pent carbon-carbon single bond. Therefore N. And this OH group is main functional group. It comes under secondary suffix. Secondary suffix for OH group is OL. This OL present at second carbon. Therefore you get 2. So 3 N-ethyl amino pentane 2 all is the name of this compound we can say. It is a secondary amine. Okay. Next case we will take next compound CH3 NBr, then C2H5 here C2H5 OH, like this we will take. Now for this compound how to say the name? What are the functional groups present? One is alcoholic functional group, another one is tertiary amine. Now which is main functional group means alcoholic functional group is the main functional group. Therefore what is the parent chain in this case? Parent chain is what means this is the parent chain. This is the parent chain we can say. So how to give the numbering, that we'll see. Now numbering we will give it here 2 carbon atoms present, therefore number 1, number 2. Okay, 2 carbon atoms. Here number 3, here number 4, here 2 carbon atoms, therefore number 5 and number 6. Have you got idea? Here 2 carbon atoms are there, therefore number 1 and number 2. Here third carbon, fourth carbon, here 2 carbons present, so number 5 and number 6 we have given. Sir, okay. Now we will see first this substituent name we will see. In this substituent, this bromine name is what means bromo. This bromo is attached to this N, therefore it is called N-bromo we can say. Next, this CH3 is called methyl group. This methyl group is attached to N, therefore we can call it as N-methyl. Now this substituent name is what means N-bromo N-methyl. This substituent is attached to parent chain at which carbon means fourth carbon, therefore 4 we can say here. Next we can say the parent chain contains 6 carbon atoms, therefore X carbon-carbon single bond is there, therefore N. This OH group is called OL. This OL present at third carbon. So we can say the name of this compound is so and so we can say. Next we'll take one of the compound called like this. It is what means cyclohexane. This cyclohexane is having here bromine and here what in the sense NHC2H5. NHC2H5. Here what are the functional groups are there? Here what are the functional groups means one is this secondary amine, another one is bromine, which is getting higher priority means secondary amine gets higher priority, therefore it comes as a secondary suffix. It comes as secondary suffix we can say. This is coming as what means secondary suffix we can say. Okay. So now we will say the name of this one. Now first we will say the bromine name. This bromine name is what means bromo we have to say. Bromine name we have to say as bromo. Sir, bromo we said. Then we will say the name of this ethyl. Ethyl we will say this ethyl is directly attached to N. So we will take N-ethyl we will say. Then this is what means cyclohexane. This cyclohexane we will write it as a cyclohexyl. This N we will write it as a amine, cyclohexyl amine. Now the bromine present at which position means it is number 1, it is number 2, it is number 3. So 3 bromo. Why we have given number 1 here? Because this carbon is having main functional group. So this carbon is given number 1. So bromine is number 3. So 3 bromo we said. 3 bromo we said. Now we can say this one in another manner also. We can say what is another manner in the sense here exile is there, no, this in this place what we can say that we will see. Remaining things same, 3 bromo same, n-ethyl same, n-ethyl same, cyclohexyl we will say as cyclohexane, cyclohexane, cyclohexane. Then this n is called what means amine. This is at what carbon means first carbon, so one amine. Like this also we can say. But here what we have to see in the sense this in this amine the first letter is A, that is called vowel sound. So we have to take out this E. We have to take out this E. Therefore we have to take only N. Okay, cyclohexane one amine is the name of this compound we can say. Okay, so next compound we will take. Next compound here bromine, here phenyl ring, then here NH, here C2H5. Here like this is that. How to say the name of this compound that we will see. Now for this we will take so and so compound we will take. What is the name of this compound in the sense this compound is called aniline. What is the name of this compound means this compound will say it as aniline we can say. So in this aniline one hydrogen, this hydrogen is there, no, that hydrogen will replace by one bond. So we can call this name is what means aniline we can say. So aniline we say. In this aniline what is there means one hydrogen is replaced by ethyl group. That ethyl we will write. This ethyl is directly attached to this N, so N-ethyl we have written. Then this bromine name we will write it as bromo we will write. This bromine is present at which position we have to see. Now it is aniline means this carbon is having nitrogen, so this carbon we have to take at first carbon because this carbon is having functional group, main functional group. So it is first carbon, it is second, it is third, it is fourth. So bromine present at fourth carbon. So we can say 4-bromo N-ethyl aniline. 4-bromo N-ethyl aniline we can say. What is another name for this compound that we will see? This bromine we will say as it is. 4-bromo will say N-ethyl, that also we will say as it is. N-ethyl we have said. Now this alone if you see, this alone if you see benzene, so benzene we will see, we will write. And this functional group name is what means amine, that we have written. Now in this amine first letter is vowel sound, so drop this E. So the name is 4-bromo N-ethyl benzene amine. N-ethyl benzene amine is the name of this compound we can say. Okay, next compound we will take. Now NHET, ET is called ethyl group. Then phenyl ring we will write. Then we will write NO2 and Cl. NO2 and Cl we have written. Now how to say the name of this compound? If you say this is aniline, if you say this is, we can say this is as aniline we can say. If you say this is as aniline, then how to give the numbering? How to give the numbering means this carbon is having functional group. So number 1, this carbon 2, this is 3, it is 4. Okay, so that nitro group present at which carbon in the sense second carbon it is present. Third carbon nitro group is present, so that 3 nitro will say. At fourth carbon chlorine is present, so 4 chloro we can say. Then this ethyl group joined with N, therefore N-ethyl we can say. N-ethyl, so that name is 4-chloro 3-nitro N-ethyl aniline. Chloro and nitro, which comes first means chloro, because C is coming alphabetically first when compared to this N. So the name of this one is so and so. Now in the place of aniline we can say another name. What is that means? Benzene amine. That also we can say. In the place of aniline we can say benzene amine. Benzene amine also we can say name of this compound. Okay, next we will go for a preparation of amines. Next we will see preparation of amines. We will see preparation of amines. In this first method is called Hoffman's ammoniaolysis method. Hoffman's ammoniaolysis method. Hoffman ammoniaolysis method will take. Now in this method what we have to take means alkyl halide we have to take. We are taking alkyl halide. This we will treat with ammonia. This we are treating with ammonia. What we are getting in the sense RNH3 plus X minus will get. then to this base is added. What is leaving means HX is leaving, so we are getting what means RNH2. RNH2 we are getting a, to this we will add RX and OH minus, we will get what in the sense RNHR. To this we will add RX and OH minus, we will get tertiary amine, we will get tertiary amine. To this we will add RX, we will get what in the sense quaternary ammonium salt, we will get quaternary ammonium salt, we will get. Sir, what is the mechanism regarding this? That we will see. First, alkyl halide is treated with what? Ammonia. Alkyl halide RX is treated with ammonia. So what is the mechanism involved in it? That we'll see. Ammonia we will take. Ammonia contains nitrogen and 3 hydrogens. In the ammonia, nitrogen is group 5a. Group 5a means this valence shell is having 5 electrons. This is making bond with the hydrogen like this. So now in the ammonia, the central atom nitrogen is having one lone pair. Now in the place of Rx, we will suppose we will take a CH3Cl. CH3Cl in the place of Rx, in the place of Rx, in the place of R CH3, in the place of X Cl, we will take a, then we will get a CH3Cl. Cl is more electronegative than carbon, so Cl is pulling this bond, so carbon is getting electron deficient, so this lone pair is attacking this carbon, this bond is migrating, so Cl minus is leaving, so we are getting a NH3 and here bond CH3, N is getting positive charge due to donation, since it is a donor. Next, so we got so we got then what we added. See, first Rx is reacting with NH3 to give RNH3 plus. Then base is added, OH minus is added. Okay, to this what is added in the sense OH minus is added. O minus is having 3 lone pairs. This OH minus is pulling this OH minus is pulling this H plus. Therefore, this bond pair goes to this N. So therefore, this H plus and OH minus becomes water. So what is this in the sense CH3NH2? CH3NH2 we can say. CH3NH2 we got. That is called this one RNH2. This is called primary amine. Primary amine means nitrogen will have 2 hydrogens. So Rx is treated with ammonia and then with the base we are getting what in the sense primary amine. This primary amine again treated with Rx. Rx means for example CH3Cl we will take. So this again treated with CH3Cl. So what is happening means lone pair is attacking this carbon. This bond is migrating. So Cl minus is leaving. So we will get CH3, this NH2 and CH3. Now nitrogen is getting positive charge because it acted as donor. Now we will add base. Base we are adding this OH minus. In this OH minus, O is having 3 lone pairs. This OH minus is abstracting proton. Therefore, this bond pair is going like this. We can say. Otherwise, in another manner also we can say. What is that? That we'll see. This OH minus is abstracting proton. So this bond pair is becoming lone pair. Like this we will say. So that what we are getting means CH3, NH. This is having lone pair and CH3. This N is having 1 nitrogen. Therefore, it is called a secondary amine. So in the beginning, you see that this CH3Cl has converted into primary amine here. Primary amine because N is having 2 hydrogens. Next, this primary amine has converted into secondary amine. Then you say this secondary amine will convert into what you say? This secondary amine will take this secondary amine. This secondary amine we will treat with what in the sense alkyl halide. Alkyl halide example is methyl chloride. Now it is attacking this nitrogen is attacking this carbon. So this Cl is leaving as Cl minus. So we will get CH3 NH CH3. This CH3 we will get this CH3. So N is having positive charge. Then we will add OH minus. We will add this OH minus is abstracting proton. Bond pair is becoming lone pair. So we are getting CH3N, CH3, CH3. Now this N is not having hydrogen. Therefore, it is called what means tertiary amine we are getting. Then this tertiary amine is treated with another CH3X. Now CH3Cl we will take. We are taking alkyl halide. This lone pair is attacking this carbon. This bond pair is shifting. So Cl minus is leaving. So what we will get in the sense CH3N, CH3, here CH3, one more CH3, nitrogen is getting positive charge, the Cl minus is having negative charge, it is called quaternary ammonium salt. Now see, quaternary ammonium salt means nitrogen will have 4 alkyl groups. Nitrogen will have 4 alkyl groups, then we will say quaternary ammonium salt, and nitrogen will have positive charge, we can say salt. Now this is called Hoffman's ammonolysis method. So in this Hoffman's ammonolysis method, first we are taking alkyl halide, it is treated with ammonia, then treated with base, we are getting primary amine, then it is treating with alkyl halide and base, we are getting secondary amine. This on treating with alkyl halide and base, we are getting tertiary amine. This on treating with alkyl halide, we are getting a quaternary ammonium salt. Quaternary ammonium salt. Okay. Now you say that in order to get primary amine as major, what we have to do? In order to get primary amine as the major. Okay. So primary amine is the major product. When do we say primary amine is the major product? When do we say quaternary ammonium salt is the major product? Quaternary ammonium salt is a major product. When do we say? If you want primary amine is the major, then you see such that it is not there. If it is not there, then it will not convert into like this. No, it is not there in the sense take this less extent. So take this less extent, take this excess. Therefore, we have to take ammonia excess. Ammonia excess. Now, this should be the major product. Quaternary ammonium salt is a major product, means what we have to take excess? Rx you have to take excess. So you have to take a Rx as excess. If you take Rx as excess, we will get quaternary ammonium salt. If you take ammonia as excess, primary amine is the major product. This method is called Hoffman's ammonolysis method. In this ammonolysis method, we will get all the types of amines. All the types of amines we will get. Next method we will see Gabriel phthalimide synthesis. Now Gabriel's phthalimide synthesis. Gabriel's phthalimide synthesis we will take. Now we will take what in the sense? First we will take benzene. We will take here. It is benzene. Now we can say what is the name of this compound? Benzoic acid. Benzoic acid. What is the name of this compound? What is the name of this compound? We can say it is called phthalic acid. It is called what means phthalic acid. Now this phthalic acid we will treat with ammonia. We will treat with what in the sense with ammonia. What is happening? That we will see. This phthalic acid is treated with ammonia. Now this OH and this H becomes water, and this OH and this H becomes water. So what we are getting here in the sense this phenyl ring, here CO group, here CO group, and that NH group. This NH group. It is called what means phthalimide. It is called what means phthalimide. This phthalimide we are taking in this process. In this process we are taking this phthalimide. Okay. Now we will take phthalimide. We will take phthalimide in the sense phenyl ring, CO, and what means NH. It is called phthalimide. To this, let us add alcoholic potassium hydroxide. Alcoholic potassium hydroxide means potassium hydroxide dissolved in alcohol. In this, we will take OH minus. We will take. So what we are taking in the sense OH minus. So this OH minus in this oxygen is having minus charge. This OH minus is subtracting proton. The bond pair is shifting towards this N. Therefore, already it is having one lone pair. So this will become water and leaves. So what is the remaining in the sense here C double bond O is there. Here C double bond O. This N is having two lone pairs. So negative charge, and this K plus is balancing this negative charge. This is the salt. This salt name is called potassium phthalimide. This salt name is called potassium phthalimide. We will say. Then it is reacting with alkyl halide. It is treated with alkyl halide. This lone pair is attacking R. This X is leaving as X minus. Therefore, we will get here C double bond O.